Student, now let's discuss the theories of the bonding in the coordination complexes or the coordination compounds. And first one is the valence bond theory or the VBT. This was given by Linus Pauling. And this theory will going to explain the stereochemical and the magnetic properties of the coordination compounds. This is the simplest theory for explaining the bonding in case of the valence, these coordination compounds. So valence bond theory has several assumptions. First assumption is that the central metal atom has the responsibility to make available the empty orbitals that will be used after taking up electrons from the ligand to form the coordinate bond. Means it is the responsibility of the metal to make the available empty orbitals. And then second one is that these empty orbitals, how they will be made available is by the process of hybridization. First, the orbitals of slightly different energies will going to hybridize to form the new set of orbitals that have the equivalent energies, and that is the second assumption, hybridization. And third one is that in this hybridization or in this mixing or intermixing process, the d orbitals which will be involved may be either the n minus 1 d orbital, that is inner orbitals, or the nd orbitals, that are the outer orbitals. And fourth assumption is that the atoms which we consider as ligand should have in their donor atoms lone pair of electrons in any particular orbital. Means they should have at least one orbital that contain the lone pair of electrons. Only that atoms will be considered as the ligands. And the fifth one is that these empty hybrid orbitals which were made by the metal, and they will overlap with the filled orbitals of the ligands that have the lone pair, or the, we can say, excess of electrons that will mix up with the ligand to form the LM bond, that is the sigma bond, covalent sigma bond, which we will call the coordinate bond. And the last one is that besides forming these coordinate bond, there is possibility that pi bonding may also take place. So pi bond may also be formed. This is another possibility. And so these were the different assumptions on which the valence bond theory was based. And but this theory has several limitations. For example, number first one is that this theory does not explain the color of the complexes, and this also doesn't explain the qualitative explanations for the complexes, and it also doesn't explain electronic spectra, and it also doesn't explain why in some cases the inner orbitals, d orbitals, or why in other cases some outer these orbitals will going to intermix, and it also doesn't explain the relative stabilities of the complexes made by the metal ion, and it also doesn't explain the splitting of the d orbitals. It hasn't considered the splitting of the d orbitals, which we will discuss in the crystal field theory. And it also doesn't explain that why different structures of the complexes have different stabilities. So these were the limitations that was with this valence bond theory. That's all for the valence bond theory.